So first of all, congratulations for your master thesis.
Thank you.
It was the most funniest conversation and interview we had. Like you all know, we are really curating the people who are here because that makes sure that we take care that people coming from Canada are not disappointed as they sometimes are if they go to Predator conferences where they are bombarded with marketing. So we always talk to everyone, and when I talked to you, you were on the streets in Montreal. It was a very good internet connection, by the way.
Thank you.
And then you immediately convinced me that I want this man here, and then you came over. So thank you very much for coming all the way.
Thank you. Appreciate it.
I have one quick edit to my slides. I'm just going to do this for Lars. Spatial computing. There you go. Hello, everyone, and hi to those of you at home that will probably watch this later. I'm going to present today on using virtual reality or spatial computing for athletes to attain flow and immersion. And so we're going to dive right in. So I've had a great time so far here, as you can see on the boat tour yesterday, and getting to know all of you. A quick couple disclosures. Oh, there's the mic. Please don't take pictures of any of the slides that have that little camera. The thesis is still being published. It will be open access soon, but I do plan to publish this in journals, so if you take pictures, it affects it. Research was funded by the university and my tax, and conflict of interest is I'm building a startup as a CEO and founder of a VR app for athletes. So I'm not going to try to mansplain to the room what VR is, but I will make one key distinction for pain relief, is that to be fully immersed in virtual reality is very important. So many people use the term VR or XR for different things, but having that full immersion is really important, and I'll go into some of the why. Any presentation I give, I always try to think of what are like some of the key takeaways that I would be really upset if the audience didn't take away from it. And being here this week, I've changed these slides a few times. I've given this presentation a few different ways, but I really want to give you the answers to some of the why, so you really get some of that detail, and then I'm going to present my data, what I can show you today, and as well as just kind of what I foresee in the future of some of this as well. When it comes to pain, I want to make sure we're all on the same kind of idea or understanding. Pain is something that has to be processed. So the brain has to actually process the information, and then you feel the sensation of pain. So that's where this all kind of ties in together. And immersion and flow. Immersion is that hopefully you're immersed in this talk and you're really enjoying it. Flow, I'm hopefully the only person in the room that gets into a state of flow. I'm at that optimal level of immersion. I look down and 15 minutes is by and Lars is already telling me to hurry up and be done. I'm at that optimal level of immersion and things are just happening effortlessly. So, pain is the most common clinical symptom that exists, any kind of pain. 50 million Americans each year deal with pain. And when I started this research, this was the question that I was looking at, and since the years of me starting, I believe the answer to is VR a significant non-pharmacological treatment is yes. We've seen a lot of use cases. I'm going to touch on 3, and we've seen some companies today, or some people that are doing research, looking at using traditional exercise to have as an alternative with virtual reality like Icarus, medications and opioids. We've seen Cora, I don't know if I pronounced it properly, but using it as a way to limit the medications that people need to take so that they can actually immerse, and traditional relaxation we've seen in the literature. And the reason for this is virtual reality is the best method we have to captivate attention, immersion, and flow. And that has to do with something known as the limited resource model of attention. So my study was founded, or I created the study over 6 months, which is a long time for a master's to try to figure out a study, but I crafted this from scratch. And I used these 3, and I'm not going to go into too much detail, but this is some of the reasons why virtual reality works. So the limited resource model of attention basically explains that our brain has a limited capacity, as incredible as it is, to process the information it receives. So if you bombard it with information like virtual reality, you target all the senses, so vision, sound, we've heard today about it, you're really able to take that brain and focus it there so it doesn't feel the pain signals that it's getting. And that's where the task-related analgesia comes in. They're linked, so that task, it's a fancy word for you feel less pain. And then the novel part of my study was the motivation decision model. I believe that if someone was more motivated to do something, they're going to give it more attention, which is going to lead to all the other stuff, so it kind of snowballs together. So I was one of the first to look at this from an exercise science perspective and healthcare, and bringing these 3 models together into one study. I'm not going to go too much into this, but in terms of sports, ironically enough, there isn't really much literature for baseball, ball sports. Most of the literature is on soccer, long-term recoveries, and training related. So there's a lot of data out there in terms of training athletes, but in terms of using it for rehab context, it's still very limited. And what's really vital for people in this room is that over multiple studies that I did in literature review, clinicians interviewed found that they don't know how to effectively implement many of these technologies into practice. Whether they don't know how to use it, or they do know how to use it, but they don't know how to necessarily use it with their clients. And so that's something that's really important. So the aim of my study, I'm not going to go into the whole words, but I induced pain, and I wanted to see how the virtual reality baseball affected the baseball players while they were doing 3 different conditions. So we induced pain with capsaicin cream, which is like a spicy pepper, and it kind of feels burning, painful, it's not very much fun. I'm not going to be able to go into too much details of the methods just because it's very complex, but we collected 4 different measures. So the pain, that's the gold standard for a questionnaire for pain. We took every minute, ratings for pain every minute. And then we did the flow in a questionnaire, which has been validated. We took the immersion scores, and then we took simulator sickness, which is, we all know what that is, so I don't have to explain it here. This is just generally what it looked like. We put the cream on. Every minute I took a pain rating from them, so we tracked it. Some people took 45 minutes, some people took an hour, some people took 75 minutes for the pain to start. So it was a very, very long study with each person. And then once we started, we went into the 3 different conditions, which look like this. So there was a 2-back task, it's known as. So it's a computer, it was an active control. So it was a computer where you sit there and these pop up on the screen. So you get one letter, and then you get another one, and you get another one. So it's a very famous psychological study called the NBAC, and you can do a 2-back, a 3-back, a 4-back, and so on. 2-back means that you have to remember what happened 2 letters ago. So if it was the same letter, you push the button. If it wasn't, you do nothing. Super simple. That was the mental component. Then this is what the virtual reality looks like in the headset. So this was a condition where they were just playing with one person throwing a baseball. Nothing else happening. It was very simple. It was known to be easy. We calibrated it for the speed for the players. And then you can see here, this is a full baseball game. So you've got people on base. If you know baseball, you've got a stadium, you've got sounds, they got a goal to do. So it was more challenging. And the reason with this is, again, motivation. A computer task, you shouldn't really be as motivated as a baseball player than a practice, and you would be more motivated to play the game. And that's what we expected to see. We expected to see the pain ratings go down as the immersion and flow ratings went up for each of the conditions. So please don't take any pictures of this. The number one finding, for sure, is that we attained an extremely high level of immersion. So this is the first measure we were looking at. So for reference, the typical average score is 125 in studies of these kinds, and the max score is 217. So if you think about almost 170, 180 out of 217 is a very high level of immersion. And that becomes important because if you want to immerse somebody and you want to track that they actually feel immersed, this is a very good, useful use case for that. Now this slide's quite a lot. I'm not going to go through all of it, but this is the flow. So that optimal state, you can see here that in both of the virtual reality conditions, we have a statistically significantly higher amount of flow than in the computer task. And then these are just other constructs you're supposed to share as well. And when it comes to pain, unfortunately, because of the cream, we didn't quite see what we were hoping to see, but we do still see quite a difference in terms of the pain for the virtual reality and the 2-back. So like most theses, when you finish, more data would be helpful to actually have bigger sample size for these things to become more significant. And what's really, really vital is this slide, where I think we can utilize some of these data points, and a PhD could come from probably all of my data, analyzing it in a much higher level of regression. I'm going to break this down very simply. What you see here is the computer task. It basically stays flat if we ignore this one point, which we don't know why it happened. It's random. These are the virtual reality, and we have what you can see is like a U. So when they're in virtual reality, the pain goes down significantly. And some people, anecdotally, I can't actually say this in a research way, but I had some people in the study put the headset on, go from 6 on 10 pain down to 0, freaking out because they're like, why don't I feel pain anymore? Take the headset off and immediately feel the pain and go right back to 6 on 10 pain, which is fascinating. So if we had a bigger sample size, we would see that more, we would have these things be able to actually be shown more. But as a person who studies this, who understands it, yeah?
Could this also be a diagnostic tool to diagnose psychosomatic disorders?
That's a whole other Pandora's box.
When you see effects like this, like 10 to 0, 0 to 10,
yeah,
it's very often also a psychiatric problem. I don't want to interrupt you. But
no, that's okay. I will say, based on the literature and what I've seen, it's generally not psychiatric disorders. It's generally it works. So I often equate virtual reality and XR, spatial computing, to acupuncture. It's been around forever. Some people swear by it and get instant relief and live their lives because of acupuncture, and some people don't. And I, for me, don't care. If this doesn't work for somebody, I'm like, okay, it didn't work for you. It doesn't cost that much, relatively speaking, in a clinic or therapy. Yes.
And it still works.
It still works, yeah.
Even if the reason is a psychosomatic.
That's true.
And you're pain-free, it works.
Absolutely. What happened to my slide? Oh, they're edited. So I'm not going to go through this too much, but the VR pain reduced during the interventions and returned after the headset took off. So no matter what the scale looked like, it actually did that on a pretty consistent basis, where you would see it go down and go back up. Some people it was only 1 on 10. Some people it was 6 on 10 would change. And this would be something very important for those of you in the room who want to immerse somebody. Virtual reality, I have data here to show you how valid and reliable immersing somebody in virtual reality is compared to something not virtual reality. You're really able to immerse them in this context as an athlete, and as somebody who's looking at athletes, it's important. But again, more genders, mixed genders, stronger pain induction and larger sample size. So now we shift away from some of the data to more of real world and some of the things that I'm looking to do over the next little bit, now that I'm not wearing 7 hats and I can start doing some other stuff. So in Canada, as you know, our winters are long, they're cold, and they suck. And so one of the things that's really important for sports is we often have to travel elsewhere, costing a lot of money to play. So when I played baseball at a very high level growing up, we would fly to Florida, we'd fly to California, because we just couldn't play baseball in the winter. So this is something that we're looking to utilize in the training aspects and also rehab. Somebody who has an ACL surgery that's going to be out for a year, or shoulder surgery, something that you can utilize this. And it's portable. So that's something that we're doing. And the key problem that I'm looking to solve as I move out of academia is in my interviews for a validation program for my startup, 75% of the healthcare professionals said that their clients don't do the recommended exercises 75% of the time. That is a massive problem that we need to solve because it's boring and outdated, and we don't really track. I lost my time record, so I have no idea how long I've been talking for. But that's okay. There it is. We're good. I got time. And that's a massive problem that we need to solve because as we move to things like Icarus being more hopefully mainstream and more fitness tools being implemented, I do believe that we're going to see people actually wanting to do their exercises in a fun way and actually recovering much faster. So we're beginning to see it in many different places. So we've talked about it. This is one of the earlier use cases by Hoffman. He's one of the landmark extreme person. I highly recommend reading his articles. Using it for burn victims, so they don't need to use medication. Childbirth, people are replacing epidurals. My wife is super excited whenever we decide to have a child to use it to be one of the use cases. She always talks about it. And retirement homes for loneliness, for mental health, many things we've heard this weekend. And this is one of my participants in my study using it for pain relief. And it's something that we see many companies, whether it's in hospitals, and I'm very happy to add many of these companies that I've actually, or people I should say, that I've seen this week onto this list. But you're always going to have traditional rehab in sports settings and in healthcare. That's always going to, it's cheap, it's the way we've always done it. That's never going to go away in my opinion. You've got hospital care that does pain relief and drugs. There's some of the companies here. Most of the virtual reality apps, although it is changing over the last little bit, are focused on fitness. They're gamification of exercise. That's great. But that is not rooted in healthcare. That's not rooted in healthcare and in rehabilitating somebody in a protocol that we have done for years. So an ACL rehabilitation has been done very similarly, although it's changed over the course of a long time. We know it helps people get better. So can we do a digital twin of much of that to make it in there? Now, since I started this research, this beautiful European company called Resol, if you've heard of it, has now become a very mainstream topic because they've created this software for soccer players to rehabilitate in an effective and safe way. So if you're curious, I highly recommend that you look into them because they're fantastic. And the value proposition, the big value proposition for virtual reality is it's engaging. It's a win-win for the therapist and the clients. So you actually are able to engage in a fun way. You're able to do your sport. There's a big mental health component to being injured. I had surgery myself. I was at home in Toronto with my mother watching soap operas all day because it was the middle of the day and there was nothing else to do. I wish I had virtual reality back then to be able to actually play my sport and still engage. Think often of, you break a finger, you can't hold a tennis racket anymore, but there's no reason why you can't still play tennis. So you can still hold a controller, maybe, or you can just use the hand tracking to be able to still play your sport, engage and immerse in it. And that is it. That's my link tree if you want to scan and connect with me. I'm happy to talk to anybody and engage for many, many things. Anybody who's met me this week has known that I talk a lot and that I'm very engaged and I have lots of ideas. So thank you all so much.
Thank you very much. Fascinating. I mean, pain and virtual